Given that a wheel rolls over level ground at a speed v, how fast does the top of the wheel move relative to the ground? And I'm going to immediately give the answer of 2v. In other words, double the speed. And you might say, like, well, how do you do that so quick? Or maybe it's intuitive to you too, because maybe you did the same thing as I did when I was a kid. And when I was riding a bicycle, I would look down at that wheel and wonder, like, how fast is that top moving relative to the ground? And after doing that long enough and hitting enough walls because I wasn't watching where I was going, at some point I realized, stop doing this. It's just double. Isn't that obvious? I don't know if that's quite how the story really went. But seriously, that was something. Maybe that's why I went to physics, because I'd wonder about things like that, right? And I can't remember if that was the motivation for me writing this. I think I actually got this question from another source, but still, true story. I do remember doing that, but like I said, be careful not to crash into something if you get too fascinated by that wheel rolling as you ride your bike, right? Anyways, let's check out the answer here, though, because I've got some cool pictures that hopefully will convey a little bit better why it has to be 2v. And so what does it show here? It says, let's read what it says. It says 2v, right? The tangential speed v sub t in the moving frame of the wheel is the same as the speed v of the wheel relative to the ground. I think I've already made that claim before about something that's rolling. If it rolls without slipping, then the tangential speed at some point on the rolling object, or really on an outer point of the rolling object, would be equal to the linear speed v at which it is rolling over the ground. But then we have two views here. One of them is called rotation in axis frame. In other words, this is just looking at the wheel, and it's maybe like somebody's running along beside the wheel and just watching it roll and seeing what it does. So in other words, we're completely ignoring the linear motion that the wheel is doing, and we're just looking at it from that kind of reference frame. And from that perspective, the top is clearly moving at a speed v tangential. The bottom is moving to speed v tangential in the opposite direction. But now if I say, okay, let's look at it from the perspective of the ground frame, where there are kind of two things going on. There's the rotation that we saw in the axis frame, but there's also translation in the sense of translational motion, linear motion, in other words, is what that is meant to mean, which means you add point by point the linear speed of the wheel. Well, if the speed of the wheel v is the same as the tangential speed, then the top, which gets that added to it, should be just twice that tangential speed v, which means that really is just 2 times the v that we were given, so hence that is the answer.